Methodical, engaging tone. This 3D landscape represents the challenge of multivariable functions in fields like physics, machine learning, and vector calculus. When you drop a data point onto a complex terrain like this, calculating the exact path to the steepest point of elevation is called finding the gradient. Calculating that path by hand requires deriving partial equations for every single variable involved. It is a highly repetitive algebraic process, where a single dropped negative sign or miscalculated fraction throws off the entire final result. The MiniWebTool multivariable gradient calculator automates this exact process, handling the algebraic heavy lifting to generate an immediate, accurate solution. This interface generates the complete set of data you need: a full breakdown of partial derivatives, the specific magnitude, the direction angle, and an interactive 2D vector field plot. By utilizing this tool, you bypass the common bottlenecks of manual derivation, turning an abstract mathematical chore into a highly visual and fully verifiable process. Your first step is matching the calculator to your specific problem's dimensions using this toggle switch. You can choose a standard 2-variable function of x and y, or expand to a 3-variable function that includes z. Locking in this selection first is critical. It dictates the underlying algebraic rules the calculator will apply, and setting the wrong dimension early on guarantees structural calculation errors later. Once the correct dimension is set, navigate down to the function input box and type out your mathematical equation. This typographical comparison highlights the most frequent cause of errors: poor input formatting. You must write your equation precisely, using a caret for exponents and parentheses for trigonometric functions, translating terms into explicit language, like x squared times the sine of y. Taking a few extra seconds to enforce strict mathematical syntax translates your human intent clearly to the machine, guaranteeing an accurate calculation on the first try. Below the main equation box, you will find a secondary, optional input step, where you can enter specific numerical values for your x and y coordinates. Leaving these boxes blank tells the tool to output the general derivative formulas. Entering coordinates tells the system to evaluate those formulas and calculate the precise vector magnitude at that specific point on the graph. With your function formatted and your parameters defined, click the Calculate button to generate your results. The output breaks down the exact logic. The first block isolates the partial derivative with respect to x. Directly below, the logic repeats, showing the steps to solve for y. Finally, at the bottom, you find the numerical magnitude and exact direction angle. Providing the formulas in this structured format ensures you receive a fully transparent, verifiable study guide detailing how the final numbers were derived. To physically verify all your mathematical results, scroll down to the interactive 2D gradient field visualization section located at the bottom of the tool. This chart plots hundreds of individual arrows across a 2-dimensional grid. Each arrow represents a calculated gradient vector at that exact coordinate location. The orientation of each arrow visually maps out the mathematics, pointing directly toward the path of steepest ascent from that specific point on the grid. The physical lengths and distinct colors of these arrows correspond to the vector's magnitude. A long, brightly colored arrow denotes a highly intense rate of change, while a short, darker arrow indicates a much flatter surface. You can interact directly with this visualization. Hovering your cursor over any individual arrow pulls up a tooltip providing the exact localized data points for that coordinate. This interactive chart provides a critical physical check, allowing you to ensure the abstract partial derivatives you calculated actually align with the real-world geometry of your function. Following these steps, you take a raw multivariable equation and reliably convert it into a solved gradient vector, a detailed algebraic breakdown, and an interactive spatial map. The generated MathJax output is cleanly formatted, allowing students and engineers to trace the logic step by step and integrate the correct methodology into their own academic assignments or technical documents. When doing calculations by hand, plotting your function into the visualizer serves as an immediate diagnostic test to confirm your manual algebra is correct. To continue streamlining your mathematical workflows, subscribe to the MiniWebTool channel for more straightforward tutorials on our free calculators. With the multivariable gradient calculator, you can confidently connect the theory of vector calculus to highly accurate, actionable results.